So quickly, as Hendrik said, I'm Ramya. I've been in performance testing and engineering in this space for 17 plus years, and performance is always one of the key area of interest. Okay, and that's I love writing, and also have authored a couple of books. It's not on performance though. So, and also I've tried my best speaking and writing about my experiences in performance testing and engineering in multiple forums. And thank you, Hendrik and Steve, for all the support to having me here to giving me this opportunity. It's a privilege to be part of PAC for the second time, to speak along with the other experts. As part of this PAC, and very, very interesting theme with Jurassic Park, of course. Thank you, Hendrik. Okay, let me quickly move on to the topic for the day. XMPP performance testing using open source tools. And I thought it's been a year for multiple forums. We have been talking about quite a lot on the change, right? The shift in the way we do performance testing because of the DevOps culture. But I thought, give me a second, there is a jet flying. Yeah, sorry about that. So it's been, so I thought it's been a while. So I'm talking about more on the shift left and shift right and how to do performance testing and engineering in DevOps. So I thought I should pick up something different this time to talk something core technically to have a different track of a session. Okay. So that's this attempt on the session on XMPP. And before I dive on to what makes TSung special or the lessons learned, I would like to spend a good amount of time behind the strategy of how to approach, how to create a workload model, and how to adapt to differences in the architecture. So basically, we all have a hesitation when it comes to non-web protocol. We think twice or thrice, am I going to manage it well, right? So I just wanted to tell you my experience in doing this engagement where how we split the whole piece of work into small chunks, and we were able to strategically fix one after the other and then make it as a successful engagement. Hope it will help you. Okay. So these are some of the bullet points that I plan to cover, and maybe last 10 minutes quick demo on TSung and JMeter. I can try to do that too. Okay. We'll start with application background. So we are going to talk about how we do a performance and capacity assessment for a messenger application. Okay, and the system under test, what we are going to talk about is the messenger application, and we are the end users for most of the popular messenger applications in the market, right? So I don't want to take time to talk about what will be the typical usage pattern or who or how the messenger applications will be used. Not just in workplace, it includes our personal connections as well. I think we live with IAM solutions. I cannot think of a day where we don't use any of the IAM solutions in our day-to-day official or personal interactions, right? So, and particularly with COVID, a lot of things became online, and the way we operate at workplace, it's completely managed with the instant messaging solutions, right? So now let me look at take it from a technical. So let me look at from a technical standpoint. So messenger application is like we have a client application. Either it could be a version which is running on a PC, or it could be the application which is running on Android or iOS devices. So end of the day, we have a client applications which is running where that is being used by the end users and which talks to the server, which is primarily for this application that we are going to discuss now. It's hosted on AWS. Okay. So the scope of the engagement, we have a messenger application. Can we do a performance and exhaustive scalability assessment? And client was very particular. Okay, I'm looking for how to assess the performance, scalability, and how do you price my server components. I have a big infrastructure with multiple servers, and I have a projections. As Hai was telling, right? So from business NFRs to IT NFRs, some of the time client will expect the performance engineering team to do that, the translation for them, right? So client was very clear on their business expectation, but not very clear on how it really boils down to the IT NFRs. From a technical standpoint, right? So this is what it looks when it comes to what is it actually expected from from the engagement. 3 bullet points to start with, right? So now we know, since we are having a mobile device is being used, we have to do a mobile device performance analysis. But for the context of this session, I'm not going to chalk anything on the first bullet point, which is out of scope, I'm considering. The second, we have an XMPP server, which is the crux of the scope that we are going to talk about, and we'll be covering it in detail. How we do performance benchmarking and scalability analysis, and then take the dots, connect the dots, and then it's capacity sizing, right? So second point we will be discussing in detail, and the third part is capacity sizing, right? So before even I get on to capacity sizing, I just want to take a minute to tell the current context when we started doing this performance system. Okay, so as I was saying, client was like, okay, can you do this assessment? And for this IM solution, it is already live. It is on beta, where it has been running in a prod for last 4 months. So they have some statistics on how the users would access, but it is very, very less number of users. But the business vision was very clear. So 2 years from now, I would have 1 million active user connections. And I just want to know whether my application is first capable of. Once the application is capable of, if you tell me that, then what is the hardware investment I might need to think of to make this happen, to make it up and running on AWS, right? And there is another method. Luckily, this client, they knew for sure that just putting a large room of hardware doesn't solve all type of performance problems. But some of the times, we end up educating the client to a very great extent that there should be a focus on application performance engineering, because some of the time, maybe in a fast-paced, agile environments, right? So sometimes we get lost to make the client stakeholders convinced that, okay, just moving it to cloud and putting it on, say, a very big hardware and just having it as an auto-scaling mode doesn't solve all the problems, and you cannot meet your SLAs, right? So we had very good clarity of thought from a business requirements were very clear, but we didn't had a good IT requirements. What is the NFRs, or how do we go about testing it? So now moving on to the third point, capacity sizing. Why should we give so much importance on the NFRs, defining, validating it, and the importance on building a realistic workload model? The reason is, it is not just about the performance and scalability benchmarking that we are supposed to do. It's on top of it, we need to connect the dots and tell them this is the hardware that you might need to have in order to meet your capacity for each of the server components. So we have a bunch of servers in our solution architecture. I'm sorry, I couldn't share some of the pictures because of the NDA. So there were a bunch of servers, and I'll explain you in detail about these servers and the kind of workload. But at a nutshell, if you look at XMPP server, it has XMPP workload, so it gets a X number of messages per second. And am I performing better, and can I meet my targets? So that's the question. So when it comes to billing and service server, it is a pure API, REST APIs that have been running. So end of the day, we need to benchmark, okay, these servers can handle X number of API calls per second to meet your business requirements. It was simple. When it comes to the fourth part, right? So we have a DB server, which is common for shade between all these XMPP workload and API workload. So with 2 different workloads coming in, we really got understood the seriousness of it. It's not something like how we have a very, how do I put it? Most of the time, the performance testing strategy for a web application, we know it. We have experienced it for hundreds of assessments, right? But when it comes to a different solution architecture with a different type of workloads, it gives an additional emphasizement on how good are we strategizing this particular performance testing solution, right? So if you look at the bottom 2 points, so with that seriousness, we realized, okay, we need to do a very full-fledged tool feasibility analysis to choose the best open source tool Client was very particular about it. And also the need for multi-phased performance testing strategy. So why do we need multi-phased testing strategy? So we know there are two different workloads, XMPP and API workload. Before I get on to XMPP, I'll spend a minute talking about XMPP, right? So we all know XMPP is one of the popular messaging protocol. Predominantly, it's been in market for almost more than 2 decades, and it started, I think, from the .com. Since it just gotten right. So XMPP being a very popular protocol, I'm sure majority of the IM solutions are implemented with XMPP. But if you look at recent times, there's a shift going on from XMPP to lightweight protocols, like including Facebook and many other big solution providers are slowly migrating from the heavyweight text-oriented XML streaming-based XMPP protocol to a lighter version like MQTT or a publish subscribe protocol, right? So in general, we know client-server communication isn't managed in XML streams. It is a text-oriented stream, and then there are quite a bunch of popular XMPP servers. And if you look at go out 90% to 95% in the market, predominantly they use the eJabberD. And luckily, we have this engagement where a client was using OpenFire XMPP server. So that gives us an additional a check. Okay, let me do a deep dive on OpenFire XMPP performance, looking at its benchmark, and then how does it perform. All that came into picture. Okay. So quickly before we move on, when we connect to a chatting server, right? So we have different number of connections. Say for example, I have 10 user contacts, wherein the other person could have 100 user contacts. So when we establish a connection, so there is a storage space that is getting allotted for every user. So that is called roster. So the roster is nothing but the number of connections, the number of contacts we have. So when we have to benchmark an XMPP server, we need to say we need to be really confident what will be the typical roster size for the end users who are going to be expected for my solution, right? So I could expect users with say average of 50, or it could be a peak roster size of 500. So the impact, the performance benchmarking for the server purely has an impact because of this one particular factor that is very important when it comes to XMPP server performance benchmark. Okay, so the next part of it, right? So the number of logins expected per second. So even though my roster size is say 500, if I expect only 10 logins per second during the peak business hour, then it is okay. But just imagine 500 connections, 500 contacts of roster with say expecting thousands of connections expected per second, then the load on the server is huge. So these are the two very critical parameters that has to be considered for benchmarking the XMPP. Okay, so so the stream, since I said it's an XML stream that is being passed, we have different blocks. How do we communicate? What kind of a data which is going in as part of your XML stream? It is grouped into blocks for making the session realistic. So one is present. So when you log in, you say I'm online, we get a message, right? We'll take WhatsApp, for example. So the moment we log in, we get an online presence status. And then there is some requests we can send, which is managed in IQ stance. And then message is more of like sending and receiving messages, and error handling could come into error stanza. So these are the bunch of blocks which should be ideally created in your XML script to make this performance testing happen. Because for XMPP performance testing, there is no record and playback. So you have to create a script. And if it is coming to TSung, we have to create the complete session as an XML file. And if it's coming to a JMeter or any other open source tools, particularly maybe I can talk about JMeter, where yes, you have a good GUI, but there were a lot of challenges where we have to use a custom raw XML to be shared because of some of the features which was not really compatible with the plugin that was available with the JMeter, right? So with that said, I think you now I understand when I think next few slides I might be able to quickly move on. So when you look at what kind of a workload when I get, for web it is very simple. So user logins and navigates and then log out. When it comes to XMPP, we need to understand as a performance engineer, we have to spend a lot of time not only understanding the technical solution, the architecture, but also understanding the end users, how they would access the application, because we wanted to create a realistic user. When I spawn my virtual user, only then I can say this is the benchmark for performance and capacity. So we were very clear. We wanted to ensure the one virtual user load what we create is equivalent to one real-time user. So we have to do a lot of checking, thanks to the beta version that was already running with 3 to 4 months. So we have to collect the production logs, spend a lot of time in creating a very, very sound, realistic workload profile. So if you look at, we log in and we create, add users, we create rooms, we do multi-user chat rooms, we send messages, we receive messages, etc. Right? Join conferences, and then we disconnect. So when we look at this, how it comes to a server. So for a server, when you look at this workload profile, there are 5 different type of users who are going to use me and send messages to me. And these are the 5 different type of users. You could see type 1, 2, 3, 4, and 5. So if you look at each of the users, type of the user, the way they interact with the server could be very different. For example, idle, they don't do anything. They just set presence online. Then maybe after some time, they just set a presence of saying, I'm away for a while. And so they keep spending idle time where the think time has to be really high, where they just set the presence. No other messages goes on to the server. Whereas in the type 2, there are a lot of activities which is happening on adding a user, removing him, get the number of users I have. When it comes to room, group, conference, again, each of the user is very different, and these are the 5 distinct profiles through which the server could be getting low, right? So this analysis really helped us to create 5 different XML scripts. End of the day, boiling down to each user is a different session for me, and separate sessions were created to manage the load for each of them. And we have tried our best to make them realistic. So that was the first step we did. Moving on to next API, I don't want to spend more time, but again, yes, we need to understand a lot of, pick up the top frequently used APIs and then categorize them from the top ones, the high, medium, low, very low. And then we have to start using the API workload to benchmark the server for the 2 components, which is the service and billing server. Okay. So now, yeah, so I just a snapshot of JMeter, how we have different type of traffic APIs bucketed into different routes, and there is a user distribution difference for each of it to meet the targets. So here comes the actual realistic workload now. When we want to run a realistic workload, so we would have an XMPP workload coming in from my XMPP clients, and then we have the clients also making API calls. So for my database server, I have to have a realistic workload which combines the XMPP and API. So this is how we have done a distributed testing in TSung and in JMeter. Okay. If you look at JMeter, we have to do a small testing with XMPP as well to bring additional realistic, profile that we wanted to create, because in real time, there is no one user who will have only API workload. They usually have a mix of it. So we tried in a way that we create a very good realistic workload, which would help us to benchmark and then do a capacity sizing. Okay. So now when this test is going on, we also have to do something else. So we have to run from our devices. We have to connect to the server to see whether am I able to open up my roster? Am I able to connect to the server and then make some transactions? Is my server good enough when 1 million users are running, right? And as we all know, the problem statement was very particular to manage a very huge load, and that's why the licensing tool was not a second thought even, because it's a huge load, a very huge experiment. So client was very particular to manage with open source solution, right? So for that, so a lot of analysis goes for a very sound workload modeling is what I wanted to bring in. Moving on to test strategy. So we started with phase 1. So we, as I was saying, we have a multi-phased approach. Phase 1 was we started understanding the API workload, and we started testing with purely it was managed with JMeter to test it for a particular connections, and we created targets. How many targets has to be purely based on a workload modeling exercise, right? So, but we of course, we had a distributed load testing setup, and then we used about 8 load generator machines in cloud to make this load generator and to test and benchmark it. So, but why API? This is again, there is no technical reason why API first as the phase one. It was for a simple reason. When we got this project, we have no idea working on any XMPP performance testing other than JMeter. So we all had an experience working on XMPP only with JMeter with no other tools. So we thought we'll just give a time for to speed up ourselves. So that's why we wanted to have a phase one where there is the team who focuses on phase one, looking at APIs. By the time phase two team quickly grooms themselves on learning TSung and then managing XMPP workload, and then coming up with a strategy to do a very detailed exhaustive assessment for open fire XMPP server. And again, if you look at, again, we have to manage with a distributed load testing approach, but it was, to start with, it was a very big challenge for us to learn TSung because of the lack of documentation, and lot of self-exploration was required to manage each of the XML, the block of lines of code. We have to spend a lot of time. But over a point, we were able to really understand and then manage it after a while. So I just want to share this experience because it would definitely help you. Though the target was very high, the huge load was a requirement, but after a while we were able to really make a very quick progress, right? So as I was saying, the benchmarking strategy was very simple. We need to see what is the server performance, whether it can manage X number of logins when we have an empty roster, when we have an average roster size of 50, and the realistic roster where we might have 50% of the end users will have, say, when I run a 1 million users, so 500,000 users will have 40 contacts on an average, and 25% and users would 10, and how the others would have 100. So how do we generate all this test data was a very big challenge. So we have to spend a lot of time creating multiple scripts, not just with a backend DB, but we have to spend a lot of time creating a lot of TSung scripts and JMeter scripts, of course, to create the test data for us to make this happen. So we were able to finalize, okay, for X number of realistic roster definitions, we can target X number of connections as per our workload model. And this is the user loads we tested, and this is the server size capacity that is required. And we have to have a lot of trial and error tests, and very, very detailed evaluations should go in for two reasons. One, first of all, we were not very clear why development team was very particular to use OpenFire instead of eJabberD, which is the most popular choice. For that, to keep ourselves convinced and then convince them whether that's the right choice was one objective. Two, to see for our workloads based on the business projections, whether it is a good choice, first of all, to meet the high scalability requirements. So we have to do a very exhaustive assessment to do the XMPP server benchmarking because of these reasons. Okay. So now moving on to phase three. The phase three was based on the results of phase one and two. We were highly confident to jump on with all servers with XMPP service and billing server on, with sending both the mutual workloads going on to the database server, right? So with that on, we have to manage, the only challenge was now, we have to manage running both the tools TSung and JMeter together, and we have to make assessment on what is the capacity that has to be there for the server to manage the target workload of 1 million users. And it's not directly jumping on to the last step. We have to do multiple trial and error runs to make this 1K all the way to 1 million. It was a very huge activity for us with multiple tuning cycles, with firefighting and triage meeting. We have to make this happen. Okay. So with that said, so I would spend 2-3 minutes on capacity planning. As I said, I would just cover it partially just for you to get a feel of why this kind of a exhaustive workload modeling and stress strategy focus is required, much beyond just a choice of the tool. That's something I think Harinder made a very good presentation, right? So choice of a tool is definitely, it's a very good enabler to make your strategy possible. But I think the real, the crux of your success when it comes to performance engagement, it purely relies on your strategy in terms of how do you manage your test environment sizing, or how do you deal with your test data volumes, or it could be your strategy, what kind of a test you do, right? So I'm sure you would agree with me. So moving on, as I said, when we do a benchmarking and when we have a very good scalability assessment, a very phased approach on phase 1, 2, and 3, it was easy for us because it was just connecting the dots, and I don't want to talk more about performance modeling and scientific laws here. But what I can do is I can quickly in nutshell say we were able to not rely on performance modeling for 2 reasons. One, we don't have a time, and we don't want to have any well, how do I put it? I mean, there are projects where it is okay when we have even a 60% of accuracy managing it with a pure modeling solution, but it wasn't the case for us, so we couldn't do that. Point number 2, other reason was we had a very custom requirement where there were a lot of differences that really expected to do a benchmarking and use the benchmarking results to do the capacity sizing. It was not purely managed as a modeling activity, for at least for this context. Okay, so we finally managed to make the recommendation on what is the server sizing to make this 1 million active user connections possible. Not just with XMPP server, we were able to plan that out for. If you look at the second column, right? So base test environment, the performance test environment, if you look at it, we start with a bare minimum instance. And we have, as I was saying, there are a lot of trial and error runs, multiple rounds of evaluation. From there to move on to the third column, what you see is the recommended capacity. So when we ran the final target load test, it was for 1 million active connections. But if you look at the first a test what we could have run, we started all the way from 1,000 users. Particularly on TSung, it wasn't even 1,000 users. I would say we have to just start a first test with even 10 users to make our script robust enough to make this happen, right? So I don't want to go deep the capacity planning strategy, but I just want to give you a feel. To make this happen, you have to rely on your sound test strategy. So that is why I wanted to share the slide to give you a feel like there is a huge difference if you could see where we started and where we ended up recommending it. So it was possible only because of the confidence we had, because we focused on the workload model, on the test environment sizing strategy, or it could be with the data volumes. We had a lot of focus on it. So moving on. What is the lesson learned? So you can ask me, okay, we have been speaking a lot of things. In next 5 minutes, I'll quickly, anyway, I'll have this presentation shared. So I would take 5 minutes to quickly finish the deck, and the last 10 minutes, I would be moving on to the deck, okay? So what is the lessons learned in nutshell? If you ask me in general, TSung was a very good choice. I mean, based on our experience, it was a very good choice thanks to Erlang, which gave it the real capability to make this happen, a very huge scalability characteristics, and which is not something which we could really make it with other tools which we evaluated. So large number of simultaneous users, a very good performance and scalability characteristics purely because it is developed from Erlang, obviously. And it supports a good number of installations because we have to manage with Mac OS when we had a local testing during the scripting phase. And then the moment we moved on to AWS, we have to change to Ubuntu, Linux flavors. We had, and very good distributed load testing capability. All this really made our job very easy. But it is not without a struggle. I'm sure because it was the first time for learning what is XMPP to do a deep dive on a performance engineering for XMPP protocol, and also TSung was also new to us. Okay, so finally, when we made this the final 1 million active user connections, we have to use 5 instances. It's a pretty large capacity machines, but still. 5 instances has to be on with the configuration to make this 1 million active connections created to create the benchmark and then finally make this a successful assessment. Okay. So now one good thing is, I mean, I mean, if at all there was a recorder, then I don't think we would have become so, so keen in understanding what is happening in the background, right? So that is something usually I feel. I mean, because there was no recorder, we were relying on, okay, we have to understand each of every programming construct, and then we have to really think about it and then strategically write every line of code, which actually helped us to learn TSung better and make this happen. So another part of it is with respect to TSung, there is the Jabber plugin, which is the plugin which is used for XMPP testing. And this XML stream that is being used when I'll show a sample script in the demo. This is not parsed by the server when you send a XML stream, right? So there is no parsing happening. So what we have to do is we have to control the data which is coming in from the server by writing our own acknowledgement requirements. Say, for example, if I have to bring all, say, 50,000 users synchronized before I have to perform a transaction, then I have to use acknowledgement, a particular acknowledgement category of global. But when I don't need an acknowledgement, I just send a request and the request is claimed as closed, complete. But if it is a local acknowledgement, again, I have to say, wait till I get the first byte of information from server, only then that request will be considered closed. So there are a lot of coding, best practices. Again, there are a lot of paradigms that we need to understand to make this happen. And to very great extents, TSung was the best choice for XMPP performance testing. It was not just because it was highly scalable. It had a very good number of user ramp-up settings. We typically look at it, right? I mean, a very good workload model is not great unless we create that during execution, right? So we have to really look at the inter-arrival pattern and the arrival rate, which is really managed very well in TSung. And it had a lot of support in authentication, different type of authentication, though we were using SASL. But again, reading a huge chunk of data from CSV file, it was a very big challenge for us to manage multiple files of test data, because it was not just the user. We have to create a lot of test data with groups, conferences, lot more to it, right? And very, very easy settings for think time. And there were a lot of predefined functions to manage the roster. It was all easy for us to just call a roster add a user, delete from a roster. So it was a lot of predefined functions we did. So we don't really need to start from the scratch and make it happen. So sometimes we have to do that, but not all the time. So that really helped us. And presence, right? So again, if you look at any tool which is not really capable of making this ready-made functions, the time for a performance tester could have been spent more on all this making it happen to create the script rather than doing the assessment for the application, right? I think primarily, I think many a time this goes, I have experienced, right? The focus becomes to ensure creating a very good script, and we get lost somewhere that we have to do an exhaustive assessment for the application, so that the time taken goes for a toss. So, but that wasn't the case when we worked with TSung, which has really helped us to make this happen. And very good reporting functionalities, and then good log level capabilities, which helped us to really reduce our debugging time. That these are the crux of it, which I'll cover, show some of the simple things in my demo. And there's the server. We have a client to check whether everything is working during the debugging stage. We used a client. And finally, with that, we created 1 million active user connections. And the dashboard, what you see down, is from the OpenFire. OpenFire is very good thing, as they have an admin dashboard, so I could see a lot of things. I mean, they have a monitoring plugin called Load Statistic. With that plugin, we could analyze a lot of metrics, what's happening at the server, and do a lot of tuning recommendations with it when it comes to, there were a bunch of configuration settings which we could tune to make all the way 1 million active connections happen. And it is only because of a TSung and very good dashboard offered by XMPP server, OpenFire server. So that's it. So I'm going to just skip it in 10 seconds pending, because it's available offline to look into it. Again, I touched upon huge data creation was a big challenge. Learning the realistic workload model, even clients were not very clear how would be the importance, or whether we need to really do this much of analysis to recreate it when you have to do performance testing. So we have to do that ourselves because clients themselves were not clear. And of course, tuning part to make all the way to make it till 1 million active connections. I mean, it was a very huge effort, and primarily to an extent for another technical reason is like we have to manage a quick learning curve. At the same time, we had a very aggressive timeline. So we have to make that happen in spite of a quick managing to have a quick learning curve, right? And of course, on TSung, it is new. We have to manage with deploying it on Mac, Ubuntu, multiple problems tuning to even start beyond 1024 users. To go beyond it, we have to do a lot of settings with play around with the settings both on XMPP a server and also on the individual client machines on the cloud. So it was a very huge experience what we had in general overall. It was quite interesting because that really helped us to understand a lot more things, how it works end of the day, right? So good thing about TSung, again, to touch upon, very good, excellent load generation. And if you look at quickly compared to JMeter, I would say 30 to 40% is what we could have achieved if we have to manage with JMeter. If we have to make this 1 million active connections, you can imagine what is the cost benefit we could achieve. And I mean, forget about the commercial tools here, because that wasn't even a second thought for us, because we purely wanted to manage it in open source tools. Else, I think if it is commercial, I think it is an effort versus cost strategy, and we have to balance it out rightly, right? So with dealing with a bunch of open source tools and making the best choice and then going ahead with it and making that happen, it was really would not be possible if we would have gone with other tools than TSung is what our experience is. Okay. Now it's time for, okay, we have next 10 minutes. I'll quickly take you through the demo. Okay. So before I start showing my TSung script, right, I just want to reiterate, right? So typically, as we all have web application, majority of us have web application experience. We log in, we pass the credential, then we start navigating across the different menus, different form submissions. We capture the parameters, we pass on, we correlate it. Typically, this is how the life of a script development team when it comes to web application. When it comes to XML streaming, when it comes to XMPP testing, we have to establish connection to the server by sending XML. I'll talk about it when I show the a piece of XML script. We have to get the user authenticated, set the presence. I'm online, so set the presence, and then I have to perform different category of operations. I think I touched upon earlier. And then finally, you set the final status, you go unavailable, and then you close the connection. Typically, this is the session, a typical user session used when I communicate with any of my WhatsApp or any other IM solution, right? So when it comes to these profiles, as I was saying, every profile was very different. So the one who does a room action was very distinct. So we have to create 5 different users. So I'm going to just show you very quick. I'll look at two simple user, idle and simple user, so that you could get a feel of how different it is, how distinct is these 2 user profile. Okay, so let me start with idle user. So this is very simple. Log level, as I was saying, we can really change the type of log level from notice to warning, and what level you use for your script debugging could be very different when you have to run a 1 million users, because it might have an impact. For example, I'll show this where you could see log level is set to warning, and dump traffic I've set it to a protocol local, where I might use 5 client machines, a distributed load testing environment, where I don't want to dump all the logs into my controller machine, the server machine, rather into the respective client machines, right? So very good configuration setting on log level helped us. And again, the next is how many clients are we using? Am I running it with a local host, running a maximum user, or am I going to use, I'm going to show 2 scripts parallelly so that it's easy for comparing it, right? So if you look at this script where we have clients, I have 5 different hosts, 5 machines, where I say each machine I'm creating typically a 400K approximate, 40K approximate number of users, whereas here I just manage with, say, localhost, right? So that's about clients. So now moving on to server. So how many server, what kind of a server settings I have to configure? It is very simple. You have to just make it programmatically work, and you have to be very confident what it is doing. That's it. So again, for once it is done with server configuration, let me move on to loop on the load part first of all. So this is the user ramp up. So it is very important piece in to make our load workload model happen, right? So two different things I would like to bring in. One, you can control with the arrival rate, which means let me, for easy understanding, I'm just going to see this. I'm going to show this. The total load duration is 45 minutes. I just put this code into a simple Excel format to make it interesting. So there are 5 phases. So I've called it, there are 6 phases. There are 6 pieces of phases written. In every phase, what is the load ramp up strategy I'm going to make? Say, for example, I say you arrival rate is 50 users per second. So I put 50. So make it in the total duration. I make it as 5 minutes. I need to make this happen. So again, this is a pure ramp up, and then it will be followed by a next phase, which is purely a steady state period. So there is a 10 minutes steady state period, though there is a very small increase in the users, 10. Again, there is a steady state. So it just alters to make this 45 minutes load test to have all my 40K users up and running. So that is the defined in this particular stanza. And then moving on, there are a bunch of options that you have to set, right? So, I mean, I don't want to get deep into it. Basically, how you're going to manage the user, whether you're going to send messages to offline user, whether you're going to pick up random users. There are a bunch of configuration settings, and are we using a parameterized DB to pull the data, test data, right? So all this will go here. And here is what I'm going to show a very simple session. So see, so here is where within one session, I can have multiple type of session. So it could be one session could do ABCD operation, wherein the second session could do EFGH operation. But here, for simplicity, I'm just showing off one session which is used within a session. So this user, they just perform, since it is an idle user, they just go on, set a status, and then they just keep setting up the status, and then keep waiting on think time just to say I'm online. And again, they will say again after think time, they'll go and say I'm away for a while. So there is no big operation that they are doing. But when it comes to simple user, they go on to first, we'll start with getting data from the CSV files. You have to do a bunch of lines, how you have to take the data, the username, password, and what is the delimiter. It's almost the same, any tool for that matter, right? And you have to have your authentication constructs ready. So you have to establish, you have to connect, bind, create a session. And once you create, you have to set an initial presence before even you start sharing, before even you set a presence of coming online. So all that you have to manage it using code, but otherwise, I mean, as long as you're clear how to make this happen, it'll be pretty straightforward. So now, so you could see there are multiple transactions. So the first transaction is now I have written, you go add a particular roster. Maybe I'll just have this. First is a roster get. So I want to go and see how many contacts I have within my roster. So I have a think time. Again, I make this, whatever presence I wanted to set, again, I can set my presences online. Subscribe I have to do because I'm first time getting to know who are there in my roster. And again, there are different things that you have to take care of it, but let's not go deeper into it. We have a roster get, and then add roster, where we have to go add a user and set an acknowledgement. You don't need to wait. You don't need an acknowledgement. And then you set up a presence there. Then you have to remove a roster if you want. And then this is the key part of it. So within a for loop, I make an online status where I keep sending chat messages. So I send approximately 120 times. The user goes on sending chat messages, and what is the size that I have to manage that has to be configured to make this transaction working. So that's it. So final transaction is closed. So this is a typical script, a TSung script you use for a simple user, which is very distinct compared to idle user, where the focus is just looking at setting different type of sending a broadcast message that I'm online, I'll be right back. That's what they keep doing. They don't perform any action. That's the idle user profile. So like this, we created different profiles. We created a realistic workload to make this testing possible, and not without the help of JMeter, of course. As I was saying, we have not only API testing, but we have to make a portion of a very small portion of XMPP traffic also generated from JMeter. So it started with setting the connections. We have to get the connection set up. Once the connection is set up, you start performing some operations. You have to perform connect, but the series of operations remains the same. You connect, you perform login, you set the presence, all this you basic operations. Then you perform some API calls, again categorized into different profiles, which I was saying you before, and then start performing different operations, right? As I was telling you before, if I have just gone with a search with a very simple message, say for example, I can make use of existing construct which is available in the UI. It could have been a very simple. So I just add a roster and I just say here, this is the new user I have to add. But unfortunately, we had our own reason why we cannot have, we required a custom XML stream that has to be shared with XML server. So we always have to send a raw XML data. It's all parameterized to manage a different type of to user, from whom, what kind of a messages to be sent. Say, for example, I'll put send message. So 2 different messages the user sends. So this big message is sent by this user to this user, and how is it managed? It's very pretty straightforward. I have a bunch of CSV files available, and there are some random variables created and used to identify a user. Every user is identified with an address. So how do I dynamically call that out? You have to manage it with calling a user with a particular resource ID. So I need to represent a user with this particular resource ID. JMeter 00011 is called the unique ID for JMeter, right? So I need to pass this to various messaging constructs. Say, for example, so here, say I have to use that resource here. So to rightly identify which user is used to send what message to a particular user. So we have to manage a bunch of a very small portion of it, I would definitely say, but definitely we have to do XMPP testing, make ourselves comfortable to make it work both on XMPP, both on workload, both on JMeter and TSung, along with the API workload, which really helped us to ensure we arrive at good sizing recommendations for the server. So pretty much that's it. So
thank you, Ramya. Very interesting. We have lots of questions. I didn't interrupt you because I was looking at the time, but you're slightly I took it longer expected, but I think it brings a lot of value. Oh, someone talking. Who is this? Maybe it's Joey. I'm going to mute himself, I think. So I'm just going to enable the webcams of the other speakers that are connected, and we can start the Q&A session. I thought that's no Stein left. Okay, I thought Stein, but Stein's not there. So let me start with the questions that the audience has asked. There are a few questions that has been already answered. A lot of questions were mainly on why did you pick TSung, and why didn't you generate 100% of the load with JMeter? Is there a specific reason why you have to combine TSung and JMeter? Because like you mentioned, JMeter has also a plugin on XMPP, but why did you have to combine both tools?
Okay, sure. To start with, the reason is we cannot afford to use, I mean, we are known with the JMeter's capability for a very huge load generation, right? So we cannot, I mean, say for example, when it comes to a very small load creation, definitely JMeter could have been the primary choice, and even that was the primary choice when we evaluated. But when it comes to a load generation of in million, we couldn't really afford to have a X number of instances additionally. Maybe I need to move to this slide to show you. If you look at the comparison of the load generation capacity, it was just 30 to 40% of what I could achieve using TSung instances. I could manage if I have to manage with JMeter. So purely because of it's built on Java and it is not having the capability to create more number of sessions from the machine. The number of machines that I would need to make this happen to create a million user connections could have been higher when we would have gone with JMeter instead of TSung. So that was the primary reason.
Good point. Question from Prashant. He said, how different combinations of server classes were decided? Like how many M4, how many lesser than that instead of all on M4? More on, because you show us what the initial sizing that was expected and then your recommended sizing. So I guess you have tried several combinations to come up to those numbers, I guess.
That's a very good question, Hendrik, right? So usually, I mean, when for a capacity planner, cost is a very important analysis that we have to take into consideration. What I mean is the cost, not only from the other factors, one from purely from an infrastructure standpoint. So because I have to have a very good knowledge on a different kind of instances and what is the best cost-effective instance, or just put it on auto scaling, whether it'll keep my economic cost saving constraints of customer, make it happen. All this kind of a cost saving analysis is very important for a capacity planner, right? So one, I would like to talk from the other perspective, right? So here, when we did for this particular client, when we look at it, that's a very good question. The reason is, when we look at that environment, what we started, it was a very simple environment where I think we were not able to manage getting beyond 60,000 connections. Yeah, it was around 60 to 80K connections. So after which XMPP server was not able to accept any new connections. So we were also testing with the client manually as well. So the server is very slow and we cannot proceed. So we know there is a benchmark we create. Okay, we know what is the CPU configuration and RAM capacity on M5 X large machine, which is available on AWS. So we have a particular number created. This is the benchmark. So now I have to try with a different other combination. Say, what if I have to manage with M5 2X large, or I should see if I have to, say for example, let me take this example, right? So I'm saying, maybe I'll take this simple example, which is very easier because it's an API workload. So I'm saying C5 machine with 8X large, I need 4 instances. So I, as a capacity planner, I need to assess not only from possibility sizing perspective, but also from the cost perspective, whether if I switch by 1x and then multiply by 24 instances, whether it would be cost effective, or should I increase it by, instead of 8x, I change it as a 16x capacity and just run 2 instances of it. So there are a multiple level of cost analysis and the scaling, a strategy that has to be checked for a capacity sizing recommendation. But purely from this engagement perspective, I would say, client wanted to get a feel of what is the maximum capacity required to make this connection, make this load happen. They were not very keen. At this point of time, it is a 2 years from now is what they were expecting the load. So because of that, all they wanted to know is, okay, I need a 8x large machine, which is running on, let's say, a quad core processor, or say it has a 24 virtual CPUs with 64 GB RAM, and I need 4 instances. Okay, so that is what I need to benchmark it for, say, 1500 API calls per second. So that is the level of information they were looking for, because at this point of time, they don't really want to get on to 8x large with 4 instances, or 16x large with 2 instances is the best recommendation. We don't really need to look at it from the current context for the client, but definitely from a sizing perspective, we need to tell them, to meet your target, this is the hardware configuration, at least feel we have to give to make this one instance from T3 small all the way to 8x CV, C5 with 8x large. What is the benchmark? T3 small could handle only 200 calls per second, whereas this 8x large machine have to handle, say 1200 calls per second to meet our workload model. So in order to move from here to here, absolutely there were n number of intermediate steps. It's not just driven immediately from T3 small to quickly jump on to 8x large. Rather, all are focused during the each phase of it, right? So each phase is to understand what is the hardware requirement. So we call it as a hardware footprinting analysis. The hardware footprinting analysis helped me to assess what is the number of virtual CPUs I need, say for a particular chip. All right, so we can use the benchmarks again. We have a good number of XMPP benchmarks. So with this two information, you can have a recommendation on, okay, why don't we try it again? It comes in a trial and error. Finally, we say, okay, we'll test it. Why don't we test it here for multiple reasons? And we test it and we make the target achievable and give a presentation telling, okay, this could be a potential hardware requirement, could be considered to make this happen for you. But now, since it is I would say a projected capacity planning, which is anyway on cloud, it is not an in-house data center. So there is enough room for them to understand what is the hardware requirement, first of all, is required. With that said, it is easy for the infrastructure planning team to go and change 8x by 16x or make it by 32x and then say only one instance I will run. Of course, it is not always a cross multiplication, but again, it would be a next level of analysis which could be required by the infrastructure team. But this for us, it was just a connecting the dots from performance testing results to see what is the hardware requirement to make that happen.
Thanks for the question. So I'm looking at the watch just because I have only 30 minutes to take grab some food. So I will ask one last question, but there's plenty of other questions. So there was one question. So one note. So there's one question about the monitoring and profiling. So did you use any specific tools to collect the right PPI indicators on the infrastructure to confirm the sizing and so on? How did you collect that? That will be a question more about the monitoring side. So you described quite very well and in detail how how you generate the load and so on. But what about the monitoring aspect?
From a client perspective, from the tool perspective, TSung doesn't have a very big set of features for monitoring. It had a bare minimum capability to check the CPU memory, the basic statistics was there. But we were purely relying on, we didn't have an APM tool available, for us when we did this engagement. We have to rely on CloudWatch, and other good thing was we had a good dashboard which we could have a lot more data coming in from the XMPP OpenFire XMPP server, which really helped us to make. Let me take that slide for you.
Yeah, I remember you showed us the screenshot of OpenFire. There was a tab on monitoring, I think, in one of your slides.
So, Are you seeing my screen now with the presentation?
Yeah, I can see your screen, yes.
Sure. So fine, I think I'm fine. With the interest of time, let me talk about OpenFire server, right? So OpenFire server had a very good plugin which pulls in all possible data including the kind of chat messages we pass on, to the size of the chat messages, to it had a very good two plugins, which I think I showed it in one of my slides. One is the load statistic and the other one is the monitoring server. So with these two plugins on the server, XMPP server, we could make a lot of insight on what is the byte, how much bytes of, what is the KB of load which is going into the server for every test. For every, we had targets not only in terms of logins, but also in terms of basically what is the size of the the message, XMPP message that is going on and handled by a server at any point of time. So that exhaustive data was very much readily available from OpenFire XMPP server with the two plugins what we had. And combined with the server monitoring, the complete infrastructure monitoring, we have to manage with the CloudWatch, because we didn't have APM tool. But at the same time, we had very good statistics. I couldn't show some of the graphs, but again, we had very good number of, maybe if I have it ready, I can show you. So if you look at what is the response time at two levels, TSung, it gives at two levels, particularly when we talk about KPI. We have a response time in terms of connect time. We have, so these two were used to check the performance characteristics, and we have a measure on how many requests handle, how many, what is the size of the request. So these are the two other KPIs on measuring the throughputs we had, apart from the session, or what is the other areas, right? Typically, you look at what is the duration of the session, whether throughout the duration of the session where the system was stable enough. So there were quite a few KPIs we were looking at, the availability perspective as well, because we took almost 2 hours to ramp up all the users to bring it to steady state. So TSung, it had a very good graphical and summary report. If you could see a bunch of transaction report, network related, network bytes, and then not just with respect to the users, but also with respect to the bytes, the network bytes, which is a very important KPI for measuring XMPP performance.
All right, thank you so much. Stein, do you have one last question? Because my stomach is telling me that I need to break.
No, I thought it was a really good example how complex performance testing can be, and it's always good to hear those stories of real projects. And it's nicely told, also completely in line with what we have seen with the previous talk. So it's only impressive to see how you can put such an amount of load for people that haven't done it. That amount of workload on the system, it's not easy to do so. And the other remark that I want to make is that people say it's always easy to use another tool. That's not about the tools, but also using a different tool can be quite complex and tricky. And that you have to be very careful using new tools, that you understand everything, like the change policy of variables and so on, that you don't do the wrong tests. But yeah, well done. I think that was quite impressive.
Thank you. Thanks, Steve. Go ahead.
Go ahead.
I'm sorry, I lost you. Can you repeat your question?
No, I was going to say that I'm pretty eager to see a blog post with because I had tons of questions, but due to the time I cannot ask everything. But I have definitely. I'm
It'll be good. Questions to me offline. I think it's a very good idea what you're talking about. I could write a blog. I couldn't attempt it before joining the session. I could definitely love to write a blog on talking about some of the challenges which our team has sent. That I can do that definitely.
Sure, that would be great. All right,
to write a book.
Okay.
Almost a book of 80 pages.
Yeah.
So thank you so much, Ramya. It was a really, really interesting session. I'd like to thank you for your investments of building the content and being again with us. It's always great.